So, radical symbol, also known as the square root symbol, but you can just call it a radical. The number underneath of it is called the radicand. So instead of saying the number underneath, you can just use one word and say the radicand is 144. Okay. There's 3 rules that you have to remember when you're simplifying or breaking down square root symbols, and I'll explain them more as we go through them. The first one, no perfect square factors can be left underneath a radical except for 1. Second one, you can have no fractions or decimals left underneath the square root symbol. So when you're simplifying these, you would not want to leave a final answer as the square root of 1/2. You can't keep a fraction under there. You'd have to keep going. You wouldn't want to keep it as 0.56 either. No decimals, no fractions under the square root symbol. And then your third rule, you can have no radical in the denominator of a fraction. So you wouldn't want to leave your answer as 2 over the square root of 3. That's not completely simplified. You can have it in the numerator. It's okay to have like the square root of 2 over 3. That's okay, but you can't have one in the denominator. And how you fix that is called rationalizing, and I will show you a couple examples of that. Capiche? All right, before we start, at the top of your notes, I want you to list all of your perfect squares. So like 1 squared is what? 1, good. And 2 squared is 4. It was hard to see the screen, so I just redid that. So you're going to list 1, and then you're going to list 4. Those would be perfect squares. Lens, what's 3 squared? Ross, what's 4 squared? Kendra, what's 5 squared? Nick, how about 6 squared? 6 squared. Good. Taylor, how about 7 squared? Megan, 8. Spencer, 9 squared. Alyssa, 10 squared. Andrew, 11 squared. Yep. Bree, 12 squared. Good. Brian, you know 13 squared? Brian, do you know 14 squared? Good. And 15 squared? 225, good. You'll want to know the first 15, not even for today and tomorrow, but for next year and the year after that, you'll use them a lot. Those are your first 15 perfect squares. These are the numbers that you're going to try and divide with today. These are the numbers you want to divide with. You don't necessarily want to look for dividing by 2, because 2 is not one of our perfect squares. You want to look to divide by 4 or 16 or something like that. It'll make your work a lot easier. All right, the first 2, I think they're kind of easy. What's the square root of 81? 9. There's your answer. The square root of 81 is 9. That's simplified. The negative square root of 225. Negative 15. Good. Square root of 225 is 15, but that negative out front, so we'll just make it negative 15. All right, 3 and 4. 3 is the square root of 16/49. When you have a square root or a fraction underneath of it, I would get into the habit of breaking it into 2 radicals. So like the square root of 16 over the square root of 49. And then just take it 1 chunk at a time. What's the square root of 16? 4. What's the square root of 49? 7. That one was pretty easy. They're not all going to be perfect squares like that, but you want to keep breaking them up. Square root 625? Any ideas what we can do? 25 goes into it? Yeah, it's got to. How many quarters would it take to make $6.25? Okay, well, how many quarters does it take to make $1? 4. How many whole dollars do I have? So what's 6 times 4? 24, and then I got 25 more cents. 25. All right. What's the square root of 25? What's the square root of 25? What's 5 times 5? 625 is a perfect square. Its square root is 25. You might see that one more often than you would expect. Okay. Those are using perfect squares. One's off your list. The next ones are not going to have just a perfect square there. So now what you have to do on number 5, we're going to simplify the square root of 28. We have to find one of those numbers that you listed at the top that can evenly go into 28. 4. How many times? Okay, so we're going to rewrite this as the square root of 4 times the square root of 7. What is the square root of 4? So that becomes 2. Do we know what the square root of 7 is? And then that just stays square root 7. So 2 square root 7, simplified. Okay, same idea with 72. That's not one of our numbers listed. So you need to find one of those perfect squares that can evenly go into 72. 9. How many times? 8. Okay, what's the square root of 9? 3. Is there a perfect square that can go into 8? 4 can. So I have to keep breaking down 8 then. I have to break that down to 4 and 2. That step 1 at the very top says you can't leave perfect squares under there. I can't stop at the square root of 8 because 4 can go into it evenly. This would become 2. So this is now 3 times 2 times the square root of 2. And since the 3 and 2 are on the outside, you can multiply them together. So your final answer here would be 6 square root 2. Zach, what did you say 72 is divisible by? Oh, you said 8? Yeah. Someone said 36. How many times? 2. So I could break 72 as the square root of 36 times the square root of 2. What is the square root of 36? 6. What do you notice about these answers? They're the same. What do you notice about the process of the answers? What? Well, yeah, but the process to get there, what do you notice? Why was that other one shorter? Good. If you find the biggest perfect square that can go into the number, then your work in the end is less. Not that 9 and 8 aren't wrong. You just have to break it down more than once. Okay, try the next 2 on your own. All right. What? Square root of 48. What perfect square can go into 48 evenly? 16. How many times? 3 or 4? What's the square root of 16? So then this would be 4 square root 3. Why'd you erase your answers? What'd you use? What'd you use? What'd you use? What'd you use?
8 and 6.
Okay, why not? It is complicated this way. Do you know why that would be complicated?
4, 2, and 3, and 2, and then just, I don't know.
Because neither of these numbers are listed where? Right. You want to try and find the perfect squares that can go into them. Then it's not as much work. Could have done 4 and 12. Anyone do 4 and 12? Did you get the same answer in the end? Ish? Okay, let's try it. You can say that 48 is 4 times 12. The square root of 4 is 2. Then I have to break 12 down. 4 times 3. The square root of 4 is 2, so this would be 2 times the square root of 3, which would give me that 4 square root 3. Okay? So you can do them more than one way. The best way is to look for the perfect squares, not that not using them isn't possible. It's just a lot more complicated. 3 square root 54. So I'm breaking down that 54. You have to keep the 3 out front. What perfect square can go into 54 evenly? 9, 6 times? What's the square root of 9? 3. So this would be 3 times the square root of 6. So you should get 9 square root 6 for your final answer. These are all connected by multiplication. So when you have them out front, you're multiplying them, not adding them together. Good on those two? Okay. Next one, the square root of 16 thirds. Break it into the two. So you have the square root of 16 over the square root of 3. 16 a perfect square? What's its square root? Okay. How about 3? So 4 over the square root of 3? We can't have that. So here comes the rationalizing step. You multiply by the square root that's in the denominator in both the numerator and the denominator. When you have a square root in the denominator, it makes an irrational number, so we're going to do the reverse. We're going to rationalize this number. When I multiply straight across, I can't make the numerator a 12 because 4 is on the outside of the radical and 3 is underneath, so you don't get to multiply them together. They just stay 4 square root 3. In the denominator, the 3's are both under the radicals, so I can multiply them together, so it becomes the square root of 9. What is the square root of 9? So this would be 4 square root 3 all over 3. Now you no longer have a square root symbol in your denominator. You can have them in the numerator, it's not the denominator. I'll give you 17 seconds to do the next one. Time's up. Square root of 64 is 8, so that's 2 over 8. Reduce that, and you get 1/4. When you know it's a perfect square, then just write what its square root is. Okay. Square root of 2/5. What do you want to do on this one? Split them into their own. So then I get square root 2 over square root 5. From there, what should I do? Yeah, rationalize, because there's no perfect square that goes into them, so I can't do any breaking down. I just have to get the square root of 5 out of the denominator. In the numerator, we have the square root 2 times the square root of 5. Since they're both under the square root symbol, you can multiply them together, so that becomes the square root of 10. Denominator, square root 5 times square root 5 would be square root of 25, and what's the square root of 25? So then your final answer is square root 10 over 5. So you can multiply when they're both underneath the radical or they're both outside of it. You simplify in the same idea. Like I simplified here 2/8 to 1/4. I didn't simplify my 2 over 64 because 2 was outside and 64 is underneath. So they have to be either both underneath or both not underneath to simplify them. How about this next one? Square root of 50 over square root of 50 75ths. What do you want to do? So what would you do then? Oh, you didn't write anything down? Okay, she said doesn't 25 go into both of them? What do you guys think? Okay, so what do you want to do with that 25? Use it? Split them up? Okay, there could be 2 different ways you can go when you say 25. When I split them up, 25 is a number listed on the top. So I could rewrite 50 as the square root of 25 times the square root of 2. And I can rewrite 75 as the square root of 25 times the square root of 3. Agree? What's going to happen to that square root 25 over square root 25? They're going to cancel out. So then you've got square root 2 over square root 3. Can't have that square root of 3 in the denominator, so we're going to rationalize. What does the numerator become? Square root of 6. What's my denominator become? 3. Good, because this would be the square root of 9, and the square root of 9 is 3. Maybe that's not what you were thinking about. Was it? Okay. Well, 25 goes into both of them, so right at the beginning we could have reduced by 25 and just made this the square root of 2/3. We would have got to the same thing. Reducing by 25 in this case and breaking them apart would also get you to that 2/3. Did any of you start it this way? Did you rationalize by 75? None of you did that? Couldn't we do it that way? You can. You're going to get a giant number up here and that you'll break down later on. But this way would also work too. So when you're doing your homework tonight, or if you're going to do it tomorrow in study hall with someone and you're doing it together and they're doing it one way and you're doing it a different way, that's okay. There's more than one way to simplify radical expressions. You can simplify first, you can break apart, you can do the long way and then break it at the end. Capiche? Okay, we're going to do one more together. We're going to do that 3 square root 7 quantity squared. Just kidding, we're going to do 2 more together. What does it mean to square something? Times it by itself. So that's what you should write down. 3 square root 7 times 3 square root 7. To square something means multiply it by itself. Now you can multiply the parts that are in the same places, like outside versus inside. My 3's are both outside of the radical, so I can multiply my 3's together. What's 3 times 3? 9. My 7's are both underneath the radical, so I can multiply the 7's. What's 7 times 7? And they got to stay under the radical. But now, what is the square root of 49? So instead of 9 times the square root of 49, it's 9 times 7, which is 63. If you square something with a square root symbol, you should always come out with a whole number, no square roots. Because those are inverses of each other. Okay, I'm going to do 14. Square root 6 times square root 8. What should we do with that? Multiply them together. What's 6 times 8? Okay, so this becomes the square root of 48. Then what do you want to do? Simplify it. Find one of those numbers listed at the top that can evenly go into 48. 16 and 3, which would become 4 square root 3. We've already done the square root of 48, but I just wanted to do the multiplying part. Your homework today will have some where you multiply them first and then break them apart, as long as you're multiplying the ones that are in the same spot. Questions? Okay. We're going to do the other ones tomorrow.